Mars used to be a lot more like Earth, and there is always some discussion on how we can terraform Mars. Like Earth at the time of life's emergence, the red planet had lakes and possibly even rivers of liquid water. Its conditions were ideal for the development of life as we know it, with the planet boasting a thick atmosphere, a protective magnetic field, and an abundance of organic compounds. However, the red planet's habitability didn't last forever. Around 3 to 4 billion years ago, Mars' magnetic field collapsed. This exposed the planet to solar wind and caused it to lose much of its atmosphere and surface water, transforming into the frigid desert it is today. It's such a tease to think that Mars was once similar to Earth. If that's the case, then surely there must be some way to restore it to its former self. If ever astronauts stay on Mars because of a long-term mission, they will need to bring something essential for survival: food. For now, Mars is an inhospitable place for humans, and it's probably just as bad for vegetation. There's a chance, though, that Mars could one day become a verdant planet. Researchers at Iowa State University have developed a means to help plants thrive on the harsh and nutrient-poor surface of Mars. This is by successfully removing salt from the water with Martian properties. Seeds, microscopic organisms called cyanobacteria, and the resources that will be accessible on Mars was all the crew needed to pull off this marvel of the future. The cyanobacteria successfully eliminated the salt by exchanging the mineral's ions, allowing the researchers to cultivate alfalfa, a nutrient-dense plant that can thrive in hostile conditions. The amazing discovery is that alfalfa somehow survived and continued to grow, and when it was composted back into the regolith, plants on Earth sprang up much faster. This kicked off a feedback cycle that could eventually lead to healthier, larger, and speedier growing space crops. Imagine the possibilities for a self-sufficient Martian city if this incredible method of circular farming were used. Farm on Mars would be an interesting feature on the red planet, but wouldn't it be annoying to wear spacesuits while working in the fields? Mars's thin and chilly atmosphere will surely be a challenge, so we will also need to warm it up. On top of that, liquid water on Mars's surface is essential for our survival. But with only 0.6% of Earth's atmospheric pressure, any liquids on the red planet's surface would either evaporate or freeze solid in no time. There are so many ideas about how we could warm the planet's atmosphere. Fortunately or regrettably, depending on your perspective, humans have a lot of practice in heating up planets. Our centuries-long release of carbon into the atmosphere has inadvertently caused Earth's surface temperature to rise, thanks to a simple greenhouse effect. We emit a lot of carbon dioxide, which works like a giant invisible blanket by absorbing sunlight and blocking the Earth's surface from losing heat. Because of the rise in temperature, more water evaporates from the oceans. It plays around as vapor in the atmosphere, further increasing the planet's overall heat. In any case, if it's successful here on Earth, there's hope it'll also work on Mars. While the original Martian atmosphere is totally gone, the red planet has substantial reserves of water ice and frozen carbon dioxide in its polar caps, and even more buried just beneath the surface. If we could somehow melt the ice caps, it could release enough carbon into the air to initiate a greenhouse warming trend. One idea from Elon Musk is using nuclear explosions over Mars's polar caps to terraform the red planet. This could be drastic, but he claims that radiation wouldn't be a problem, since the explosion would occur in space over the poles. Still, the resulting heat would vaporize the frozen carbon dioxide, causing the planet to warm up like a greenhouse and melting the water ice. That's one scenario. According to scientific estimates, melting the water ice may blanket the planet to a depth of many tens of meters. Yet it likely wouldn't last long. Even if we mined all of Mars for carbon dioxide, the atmospheric pressure would only be around 10 to 14% of Earth's. Hence, the planet's carbon dioxide supply is insufficient. If this were to happen, average temperatures would climb by only around 10 degrees Celsius, which is not nearly enough to keep water in liquid form. In other words, in order to warm Mars sufficiently, we'd have to pump more carbon dioxide. And by more, we mean more than humanity has ever exhaled on Earth. Given our technology, it appears impossible to do this at this time. However, there might be another way. We can artificially release heat-trapping chemicals like chlorofluorocarbons that are more effective than carbon dioxide. The problem is that these gases have short lifetimes. Thus, the process would have to be repeated constantly to maintain the desired temperature for Mars. In this case, greenhouse gas manufacturing factories, fueled by solar energy, would have to be built on Mars, but this would take years. Nevertheless, this might be a good strategy for maintaining the cyclical nature of the situation. It's paradoxical that we need to build factories to make Mars habitable, but we must shut them down here on Earth to save our planet. Another outlandish idea involves importing gases by causing comets and asteroids to crash upon Mars. If an asteroid weighing 10 billion tons could be crashed into Mars, its energy would be enough to cause a 3 degrees Celsius increase in the surface temperature of the red planet. If we do this for 50 years, a few of these asteroid crashing activities may bring about a moderate temperature and enough water to fill 25% of the red planet's surface. However, because each asteroid releases energy equivalent to 70,000 1 megaton of hydrogen bombs, their constant strike would prevent human colonization of Mars for centuries. Unfortunately, that's not the end of the challenge in terraforming Mars. The creation of a breathable environment on Mars is another obstacle, but there's an effort being made to create oxygen from carbon dioxide in Mars's atmosphere. Behind this experiment is no other than our new Martian buddy, MOXIE. MOXIE is a toaster-sized experimental instrument aboard the Perseverance rover focused on taking abundant materials on Mars and converting them into usable things. These could turn into fuel, breathable air, or even water if combined with hydrogen. If successful, such technology might be used by future human explorers to produce oxygen for their dwellings. But this doesn't give us carte blanche to explore Mars fully, because it might be impractical to implement this system on the entire planet. Because of this, some scientists have looked to a more practical possibility: living forms that have already impacted Earth's atmosphere. About 2.5 billion years ago, cyanobacteria used photosynthesis to transform Earth's atmosphere. A long time ago, it was just a mixture of methane, ammonia, and other gases. But thanks to these bacteria, we now have the oxygen-rich environment we enjoy today. This is why scientists have proposed importing Martian microbes that can photosynthesize in low light to produce oxygen for humans to breathe. Since the red planet has different conditions than ours, researchers suggested introducing specialized microbes to Mars that can adapt to the Martian environment and produce oxygen. When combined with other organisms, a perfect mixture of gases might form a whole life cycle on Mars. Amazingly, some microorganisms, like lichens, which are really complex organisms, were able to live in a container with Mars-like circumstances for 533 days. This is a tremendous result. But for a breathable Mars to be created by microorganisms, time is the biggest enemy. A study says that even extremophile creatures, uniquely adapted to the Martian environment, would need at least a few thousand years to create a habitable atmosphere on the red planet. But even if we could put enough carbon dioxide and oxygen into Mars's atmosphere and keep liquid water on the surface, these Earth-like conditions might only be temporary. The MAVEN mission of NASA has shown that atmospheric loss on Mars continues even now. Due to its absence of a protective magnetic field, Mars will continue to have its atmosphere and water stripped away by the solar wind. And sadly, it will just either undo or severely deteriorate our efforts in terraforming it. If we want to successfully terraform Mars, we'll have to manage the planet's weak magnetic field. Unfortunately, we do not have the means to rapidly re-energize a planet's magnetic field by accelerating its core rotation. But in theory, NASA scientists have shown that a magnetic field could surround Mars and shield it from the solar wind if it is positioned in the right spot. The ideal location is at L1, the midpoint between the Sun and Mars, where the gravitational pull of both bodies is almost equal and roughly canceled out. They believe a magnetic field on Mars with a strength of 10,000 to 20,000 Gauss would provide an adequate barrier from the solar wind. The concept may seem out of touch with reality, but for now, we can generate a field of approximately 2,000 Gauss at the Sun-Mars L1 point. Such initiative is surely impossible today, but we are on the way. It took Earth billions of years to evolve to become a place where life might flourish. So even if we do manage to get to Mars this century, it might take many millennia to fully terraform the red planet. Mars is a cold and arid globe, and to make it habitable, it will need the innovation and effort of humans for many generations. For now, we simply aren't that advanced to implement either of these ideas. But will we ever be able to change Mars into a habitable place? Yes, of course that is possible. No rule of physics stands in our way. But I wouldn't hold my breath. What are your thoughts on a Martian life? Share them in the comments section below. Don't forget to hit the subscribe button and leave a like. Thanks for watching.